welcome back. This is another IPS Podcast. This is Podcast 1.4, Chapter 1, our fourth podcast. This one is about something called dimensional analysis. Now, let's go back for a second. And if you remember the first podcast, one of the things that we stated was the language of science is math, and the units tell the story, which means we can have this, data in these big numbers or small numbers or decimal numbers, but we don't know the actual meaning of that number until we know what the units are. Now, one of the things that dimensional analysis does is it deals with making sure the units are the same, and we are able to relate the amounts to the units, and that gives us a good precision, gives us a high precision. So it's something that we're going to be using a lot. In fact, probably every day for the rest of the semester. So dimensional analysis uses ratios to convert amounts from unmanageable amounts to manageable amounts. So we take a look here at, we have 1 meter here, and we also have 100 centimeters. We know those two to be the same. And so we can write a little equation down here saying that they are equal. And actually, we can reverse that. 1 meter equals 100 centimeters, and 100 centimeters equals 1 meter. But if you use one of these, and let's move one of these, another one, that one, there, and divide them. 1 meter divided by 100 centimeters, or you can actually do it the other way around too. 100 centimeters over 1 meter, that's on it, there we go. That is always going to equal 1. And so this ratio of one similar thing, or one thing that's the same as another thing, over the top of each other equals 1. And you can do this in all sorts of things. For instance, I like donuts. 1 dozen donuts is equal to 12 donuts. That over the other, 1 dozen over 12 equals 1. And 1 kilogram over 1,000 grams also equals 1. You do it with time, 60 seconds. Cross that out. 60 seconds over 1 minute. That equals 1. And so all these equal 1, which is beautiful. So when you have a ratio that equals 1, you can multiply by 1 without changing the value. You can just convert the product. So I have two examples here. We have 41 meters equals centimeters. How many centimeters does 41 meters equal? And we have the same thing in reverse. We have 41 centimeters, and that's equal to how many meters? So when we do this, 41 centimeters, we're going to multiply by that ratio. And so we're going to set the ratio up, and we can do it one of two ways. We can set meters on the top and centimeters on the bottom, or we can put centimeters on top and meters on the bottom. Take a look what happens. We can now cancel our units. Because units on the top and units on the bottom allow us to cancel them out. So now we have 41 times 100, and that's going to equal 4,100. And our final units are centimeters, so they go right there, centimeters. On the other way around, we have 41 centimeters, and that equals meters. We're going to put this in a way that reverses those two. So I can cancel out centimeters again. I'm left with meters. And so now we have 41 times 1 over 100, or 0.41 meters. Either way, we're using dimensional analysis to convert these units, to go from centimeters to meters, or to go from meters to centimeters. And when you multiply by 1, you don't actually change the actual amount. 41 meters and 4,100 centimeters are equal to the same distance. Same thing with 41 centimeters and 0.41 meters. They're the same distance. It's just the units that you are changing. And this is important if you go back to our Tracks of a Killer lab, when we needed to have everything in meters. And remember that one or two people that would put their units in, their numbers in centimeters and mess everything up. Well, if we keep everything in meters and convert everything to meters, then we'll all be on the same page. It's kind of nice. So I would like for you to do a little practice for tomorrow. And so that means we're going to have to type one out here. Let's make this a little smaller. So we'll start tomorrow's class. We'll finish up the Tracks of a Killer, and then we'll do this problem. And we're going to say using dimensional analysis, and we're going to just say, we're going to abbreviate it, DA. Using dimensional analysis, convert, let's say that we're going to have a birthday party tomorrow, and we're going to bring some donuts. And I'm going to order 28 donuts. But when I go to the grocery store, they're going to only be in, grocery store or bakery, they're only going to be sold in units of 1 dozen. So I need to figure out how many dozen donuts I need to purchase if I need 28 donuts. So using dimensional analysis, convert 28 donuts to dozens of donuts. Keeping in mind that 1 dozen donuts is equal to 12 donuts. So do that one for tomorrow, and then we will do some more. You'll get a packet, and you'll work on that tomorrow in class. Don't forget you have a test Friday. So that's 9. Let's see. 17, 18, 19, 20, 21. Test 921. Thanks a lot. Talk to you soon.